In the previous video, I showed you dropping the event keyword here allows or causes the compiler to create the add on and remove on methods in the background, then privatizes the field so we cannot directly invoke it. We can actually do this ourselves if we need more control. I can privatize the field, private, and then let's kill the event keyword. So now my delegate reference is private. I can't directly access it out here. See, it's not even showing up in IntelliSense. Okay, and then I can say let's make this lowercase just so we don't have a name clash with what I'm about to do. I'm going to say public event mooing, and then in here I can say add. I can say remove. And let's see, why is the... Oh, I also have to specify the event type. Action. Alright, so KD, bring that all in. Alright, Control KD, that's why I said KD. Control KD to format the whole document. Okay, and then down in here, just to show you how this works, let's CW, adding, and in here, oopsie, CW tab, removing. Alright, so now I have this separate delegate reference completely under my control. And then I have this add and remove. So if I go down here and I say c dot mooing plus equals, let's just throw a lambda here to get it to invoke, and I'll put handler out here because generally we call the methods that subscribe to events handlers. Watch what happens. I'm going to F10 to step into this, F10, F10, F11. The plus equals causes the add to be invoked. And notice I'm actually not doing anything in here except tracing. Here's the trace statement that prints, and then come out here and the program terminates. I didn't save away anything. Just like properties that you explicitly implement yourself. And there's this automatic or ghost value parameter that's just implicitly sent in. And we can do something with that. So an intelligent thing would actually subscribe value to mooing here, and mooing plus equal or minus equals value. Alright, so we can see the add, remove, and we can also subscribe and unsubscribe. But I could do whatever I want in here. I'm printing, and then I could say, hey, you know what? If you subscribe, you get a 3 for 1. I'm gonna call you 3 times. All right, it's totally arbitrary what I want to do in here. Hopefully, something more intelligent than these contrived examples I'm making for you. So let's go down here, and I'm gonna split the screen again just so we have more screen real estate. Don't blink. We're getting a little tight in here, but at least you can see both the cow class and main class now. I'm gonna come down here and I like to, I have a coworker that would get mad if she watched this video, but I'm going to say public void push sleeping cow. Right? I've heard of this. I've never tried actually doing it. I want to know if cow tipping actually works. I think it'd be fun. That, or I can watch cars and watch about tractor tipping. But say we push the sleeping cow, and there's a bunch of stuff that happens here. But eventually the cow is going to moo. All right? So we can't say mooing directly, because mooing now refers to code. I mean, this is just code. I said it's an event, and it is an event, but here's the add-on method, and here's the remove-on method. And you can reflect this and see that this is extremely similar to what the compiler did for us in the previous video. But I can touch this delegate reference, so I'm going to lowercase this m and just invoke that delegate directly. Now, if I'm a professional, I'm going to make sure that mooing is not null. Make sure I have some subscribers before I go and try to invoke it, otherwise I get the null reference exception. So now we're going to go over here, and I'm going to say, let's stretch this out so we can see the output. This is the handler. Actually, if the cow moves, I'm going to giggle because it's fun to push over a cow. And then I'm going to say c dot push the sleeping cow. Alright? So here we go. F10. New up our cow. Subscribe to the cow's mooing event with our giggle there hiding behind the screen split. And then F11, and well, here you can see actually we have some output adding because we called the add. But then I'm going to push the sleeping cow. Alright, so F11, we come. Sure enough, there's a subscriber. In fact, remember, I got the 3 for 1. So now my output is giggle, giggle, giggle because in our add code we did whatever we wanted to. Anyway, So here's add and remove. As this example stands, if I remove these extra two plus equals, this implementation, besides having trace statements, let's remove the trace statements, this implementation doesn't bias anything over just saying event on this thing, uppercasing this, and letting the compiler do the rest of the work for us. Okay, and we also have to turn it back to public. But in the next video, I'll show you one strong motivation for having this add and remove, and it has to do with memory and saving RAM.